today we are doing the review for the midterm exam. And the midterm exam, well, we're going to discuss what the test is going to look like. And then I'm going to take all of your questions and make sure that you're all feel comfortable knowing what's going to happen on the midterm, and we'll go from there. All right. So let's go over to the document cam, and I'm going to give you the basic structure of the exam first. Some of you have had classes from me in the past, and some of you have not. So my exams have some common elements. But the first thing is the midterm exam will be proctored, meaning that it will not be a take-home and it will not be a due on your own. So if you're here in the classroom present with me, the easiest way to do that is to take your exam at 10 a.m. on Wednesday, and I will proctor for you. The exam must be completed by 3 p.m. on Wednesday, October 17th. And that's because I need to get your midterm grades in. Now, you may also notice I'm a little behind on my grading on your homework. So today I will catch up on your homework. And all of the grades on your homework should be entered and recorded by the end of the day today. Now, I've not identified any problems with people's homework. In the past, if I have people who are laboring under some misconceptions, I bring it to their attention. But in this class so far, I haven't seen anything like that. So, so the fact that I've not addressed anything like that with you, like, you know, you really need to remember to do units, or 8 decimal places is too many, that means you're good. Yes, sir?
With the actual submission of homework, I had this problem where my phone, I don't have a computer at the moment, so I just use my phone to submit my files. And for some reason it was not working. By the time I actually got it to work, the file disappeared because it was past midnight, and so I had to do like a late turn.
Yeah, that's
fine.
fine.
I didn't know about it, so like the next day I
yes.
finally got it.
Well, I'm pretty liberal on that.
Okay.
So, I mean, I did the late homework submission button for 2 reasons. And let me just pull that up on the screen here so that we can talk about it. But one of the reasons was, and it's not so much with face-to-face, but with distance students. Oh, good, my internet's not working. That's awesome. Let's see, there we go. So with distance students, in past years, I've taken homework via email, and I just really can't do that due to my own organizational skills. It's just too easy to lose something, to misplace things. And so when I have everything in Moodle, everything is ordered for me. But I had a lot of students who, I guess the expression that I would use is they play chicken with Moodle. You know, it's like the assignment's due at 11:55, and so they're in there at 11:53 hoping everything's going to go just right. And I realized that is not an effective, it's not, it shouldn't, I wish that people would do it 2 hours early. However, if they don't, what it means is that they should still get credit for their homework. I mean, having an organizational difficulty should not cost you a homework grade. So that's why I wanted to do it that way. But as you see, I still have a late homework submission here that I need to grade. But that's you, see? But I take those things into account, and I'm very liberal with the grading. The one thing that I really want students to understand is that if you do the homework before the exam, that I feel like it will help you get ready for the exam, which is ultimately what the homework is about. Because fortunately or unfortunately, I'm very aware that on your homework that you can copy it or that you can use Chegg. And I also know that the solutions manuals are also available. And so this is why the homework is only worth a maximum of 20% of your grade, because I would like you to use these things as a guide, but if you use them as a crutch, or if you just copy from them, I can't really control that. So that's why your exams are worth so much of your grade. So anyway, the point of that being is that the homework is graded, but I grade it for form as well as content, because I know the content is available. So what that means is that if you get your homework in philosophically before the exam, you're going to get almost all of the credit. If you turn it in later because you're between an 89 and a 90 and you want an A, you're going to get less credit, but it could still help. But it doesn't help you on the exam, which is really the point of the homework. So does that kind of get you? Yeah, so when you use that late homework button, you know, the chances are you're going to get full credit or nearly full credit. So even if you're a day late or something like that.
I was just like, I'm like,
right.
I can't send it, I'm tired.
I know, I was like, ah. And then I wanted to tell Christian especially, but the program Office Lens is just super. I mean, I just love this thing. And even more in another class I have, which is business math, which is a general education math class, I showed my students that program, and they use it like clockwork, and so it's super. It's just I do that with documents, you know, that need to get fax like a 1980s technology. But you know, if you need to email something, it's just the best. So it's really good. Thank you for bringing that to all of our attention. I do not fax, but there are places who require faxes, which is, oh my gosh. Banks in the Midwest, they all want you to fax stuff to them. Don't ask me why. It's the most ridiculous. It's the most ridiculous. It's seriously technology from the 1980s. And I mean, it was a big deal then, but it's like, I don't even understand it. But some people require fax. So, 80s, yeah, it was a long time ago. The 80s was a long time ago. Wake up, it's a new century. It's a new world. So, anyway. All right, so talking about the midterm then, the first thing is there will be 4 problems, 1 from each chapter, and they will be equally weighted. My feeling is that as engineers and professionals, the most important thing that we have to do is to construct the problems. And whenever we have a problem, I always say every word problem. Is like an essay question. Because really what we do as engineers is we figure things out. The math is important, but the analysis and the setup is at least as important. So I grade everything by partial credit. So you need to do, if you recall, the homework template that I provided you with at the beginning of this semester, which is still on the Moodle page. I mean, I don't mean like you have to draw square boxes or double underline, but this sort of a problem construction is part of your grade. An answer with no work is very meaningless to me. So, and I've had students try to justify that in different ways. I've had students tell me, well, I can do the math in my head, and I tell them, yes, so can I. But I do not have a CAT scanner to look at your brain, so I need you to write it down, because that's what I'm grading you on, is not your ability to come up with the answer, but your ability to think your way through to the answer. It also means that if your work is correct and you don't get the right answer, you're going to lose very little credit, okay? I look at it to see where did that person lose the credit. And if you... I'm a little more concerned with place value than I am with numbers. You know, like if you type in, if you have 17 times 24 and you have that clearly written, in the next line you have, 3,480, I would be somewhat concerned. If you get the wrong number, but the correct unit based on your dimensional analysis, that counts for pretty good partial credit. So everything I do, I don't grade your homework with a fine-tooth comb, but I do grade your exams very closely. And I try to provide feedback in terms of critique if you have made some pervasive errors, which once again, like I said, I haven't seen that really on your homeworks. I haven't seen anybody consistently forgetting to put units, or, which is a big one, or consistently forgetting to draw a picture. But if I make a comment on your homework that says make sure you draw a picture, I mean, it's not an idle comment. It means I really want you to draw a picture. So, but I haven't noticed anything like that in here. So but those are the sort of things. When I make comments, it's a critique to help you in the future. The reason that I use this homework template is because this is what is expected of you across different disciplines of engineering, and it's still the gold standard for some of the work that's done in engineering. Even if you have a computer program to do simulations for you, there's still handwritten work that you're responsible to do. And I don't think I have any civil engineers in here, but Christian, you may be, I don't know if you have to work with survey data or what the laws are like in Germany, but here in the United States, for example, land surveyors or civil engineers who are doing surveying have to keep handwritten notes, and handwritten notes are actually held to a higher standard in a court of law than documents that you develop from a data collector. So even though there are very sophisticated ways of taking and reducing millions and millions of data points, the notes that a surveyor writes down in a little handheld notebook are still the absolute gold standard in terms of data. And that's sort of what this is as well. If you're ever called into question on replicating your work, or if you've done part of the work and somebody needs to follow up and start, they don't want to start at the beginning, they want to start where you left off. So having a good record of what you have done and why you've done it allows your entire system, the people who follow you and the people who are evaluating you, to do that better. So that's philosophically where all those ideas come from. Okay, so everything is partially graded, but everything is equally weighted. That means that 25% or 25 points from each chapter. And so the first chapter is going to be sigma and tau, right? And it could be on an oblique surface. Or it could be something that involves method of joints or method of sections. Okay. The second problem would be from chapter 2, and this is where we're going to start talking about stress and strain, sigma versus epsilon, or tau versus gamma. Okay. And in addition to the idea of sigma and epsilon, tau and gamma, we could also have something as an elongation as a function of a change in temperature. So in other words, these generally tend to be statically indeterminate problems. So we have to use the analysis of deformation. Then number 3, of course, comes from chapter 3, which most people actually find to be quite a bit simpler. Chapter 3 is, generally speaking, the easier of the problems. So we're talking about torsion, and accompanying tau, and also power transmission based on some sort of a rotation in a shaft. The shaft will either be circular or hollow circular. Okay, because that's the only configuration that we have looked at geometrically. Yes? And then number 4 is the last chapter that we've covered, where we are talking about composite materials, but the only composite material that I use to teach that idea is reinforced concrete. And so we talk about the pure bending moment, and specifically we're going to talk about reinforced concrete subjected to a pure bending moment. Okay, so there are your 4 problems. Now, in terms of what you can bring into the test, you can have a formula sheet, which is a standard size sheet of paper, 8.5 by 11 inches. You can write on both sides. You can write anything you want, as small as you want, but everything on it has to be in your own handwriting.
One question.
Yes.
He was asking about the 8.5 by 11.
Yes.
Is that the paper?
Yes.
Okay.
That is a sheet of paper that is this size, a letter size sheet of paper. Okay. So you can use engineering comp paper if you want. You can use an unlined piece of paper like this. You can use a piece of paper that you tore out of a notebook. But the important thing is it has to be in your own handwriting. So even if you're working together in a group and you decide that Eddie has the best handwriting, you cannot photocopy and use his. It has to be in your own handwriting. And that is also a study technique that I have found to be effective for students, even if they don't want to do it. It's just effective. Even if you each do part of it and you work together, if you write down what your classmate writes on a sheet of paper, it will help you to be able to retrieve that information and put it into the real world, which is where you're tested instead of in your brain. So that's where the good stuff happens. Okay? So the other thing is that let's talk about how long we have for this exam. Well, the question is, the answer to this question is we have to have fairness. Okay, which means everybody has to be able to do the same thing, which means that we can have 1 hour, or we can have 1.5 hours, or we can have 2 hours, depending on everybody's schedule. So what I'm going to do is allow you guys to discuss this among yourself in just a moment after we answer some more questions. And then for your classmate who is elsewhere, I will let him know, and then he can work with his proctor because his time is a little bit more flexible. But for you guys, if you want 2 hours, we have to find a 2-hour block that everybody can take it together, or that most of you can, and I'll work with somebody else. But if not everybody can do 2 hours, nobody gets to do 2 hours because that is not fair. Okay, so so there you go. What questions do you guys have for me?
We got questions about homework.
Oh yeah, talk to me.
Yeah, like the first 2, we're like, oh, this is good, it's easy, we're all smart. Then we tried like the one after that, like, oh no.
Number 47?
Yeah, we got stuck on some technical things, and we just like, nah.
Okay, let's take a look. Before we
You want me to get up the problem because we took a photo of it.
Sorry?
We took a photo of it, so you don't have to go through the.
Oh, super. Okay.
And
All right.
I believe Christian posted it, and he did.
All right. Super duper.
Some miracles.
So it's 47, huh?
Yeah.
Okay, let's see where we are. Oh, look at you. Excellent.
And so we knew the 4 inches x minus 4.
Okay, let me put this up here just so that we can get a picture of it. Right?
I don't think that's going to help a lot.
I know, but I just want to make sure that your classmate has this so that we...
Yeah, they all have it. It's on a group chat.
Does the other guy in Cyberland?
Oh, no, we just...
There, see, that's what I'm saying.
We don't know Cyberland.
I know. That's why I'm asking. So I'll give this right back to you. I just want to... this is, for Cyberland, this is where I'm going to start. Okay. So problem 447. Dane, I'll give you back your phone. So what are we doing now?
So, we were getting lost on... What was that?
I don't remember what they were doing on.
We figured... Yes, okay, first off, we were trying to figure out... we were using Chegg, but we were using it to, like... We just look at it and try
Perfect.
to understand which
Yep.
what was meaning what.
That's what we like.
And the area of
Yes.
steel.
Yes.
We're wondering... yeah, in its version, it had a 2 on there, but it had a different... It had like a 12-inch here.
Right.
So we're trying to figure out what is that.
That is a super super question. All right. So on 447, what we have is a slab of concrete, right? And embedded in this slab of concrete are rebar, pieces of rebar. And it says they're 5/8 inch placed on 5.5 inch centers. Okay, that means that the center from one to the other is 5.5 inches. Okay, there we go. So it says using an allowable stress of 14 and 20 for the steel, determine the largest bending moment in a portion of the slab that is 1 foot wide. Okay, what they're talking about, this is like a garage floor, and it just goes on and on and on forever. So, but what we're saying is we're just going to look at 12 inches of this particular slab. So if we went from 1 end to 12 inches, how many of those rebars are going to be in that slab?
Isn't it 3?
Huh?
Isn't it 3?
No. If you go 5.5 plus 5.5 plus 5.5, that turns out to be 15 plus 1.5, which is
Yeah. My bad.
16.5. So how many rebars are there?
When I look at it, I was assuming that for some reason it did not start at the rebar. It started like...
Well, it could, but if you think about it over an
I
average,
was wrong.
how many
It's
are going to
okay.
be there?
I'll take
Right.
it. I mean,
So
I made a mistake.
2 of them are going to be in 12 inches. So that means that the area of a single piece of steel is pi d squared over 4. But in 12 inches, that's going to have 2 pieces of rebar.
So it's 2.
Mm-hmm. And then finally, you'll have to compute NAS, which is that ratio. So you'll find this number.
What is N again?
N is the ratio of the moduli of elasticity. So, is that funny?
It just like I don't know how to comprehend that. I'm just like, oh, okay, yeah.
I've never really had anyone find the word moduli funny, but that's okay.
Like,
We all, to each his own, all God's children, right? So, sorry.
What is the modulus of elasticity? Just the median of it, or
No,
a certain
the modulus of elasticity is when we are talking about normal stress and we plot sigma versus epsilon, while we are in the elastic range, the modulus of elasticity is the slope of that line.
Gotcha.
So in other words, it indicates the stretchiness of the material, how well it responds, or how much it elongates or contracts when it's subjected to a normal stress.
Okay.
So what we're really talking about when you talk about the ratio of moduli is you're comparing how stretchy steel is to concrete. So it's the number of times more amenable to deformation steel is than concrete.
It still is a lot.
Oh my gosh, yeah, that's why it's there in the first place. If concrete was better behaved, we wouldn't even need it. We wouldn't even need the steel, right? I mean, that's the thing.
See, that is really interesting.
Well, it is. You know, a few years ago, when Powell High School, or excuse me, Powell Middle School was rebuilding they have a big, kind of like an atrium out front. You know, they redid. Did any of you guys go to Powell Middle School? That's what I thought. Okay. Did you go to the old one? Okay, so have you seen the new one? Well, it's very fancy. It's very nice, but they were laying concrete in this big, wide atrium. Excuse me. And before they poured the concrete, I got to go. I mean, I was just on a tour. I don't know what I was doing, science fair or some weird thing. But anyway, they had all the rebar in place. And so they hadn't poured the concrete yet, so I actually got to see the rebar in place. It was really interesting. The other thing that they did, we're not talking about this here, but if you're going to have a very heavy load on top of a reinforced concrete slab, you can pre-stress the rebar. So in other words, you put it into tension before you pull the concrete. So you put like, you put winches on it essentially, or you pull it with a system of pulleys, and then you pour the concrete on top of it, and then when the concrete dries, you remove the tension. Well, what that does is the concrete then keeps the rebar in tension, and the tension, what it does is it pre-stresses the concrete, I guess is what you would say, so that it has even more ability to handle an added load. So that's kind of like the final step. Like if you're building a tall building, or in that case, that humongous atrium in the middle school, that's what you would have to do. So it's kind of interesting. But this number just tells you basically what sort of a stress advantage you're going to get by using steel in the bottom of the concrete.
Okay.
Helpful?
Very.
Sweet. What else do you want to know?
There was one more thing, and it was with the, can you call it tricaster?
Yeah, I got you.
Okay.
What is it?
We have one question because we don't know where to go from here. So
Okay.
to grab it quickly.
Oh.
And it is chapter 4, right? 47.
It's still on 47?
Yeah.
Yeah.
Okay.
You need chapter, what is it, 48? Okay, on 50 you need chapter 47, so.
Oh, on problem 50, you need to have 47 solved.
Yeah,
Yes.
so we couldn't attempt it unless we got 47 done.
That is correct. And it will work out, the steps of 50 will be nearly identical to the steps of 47.
Yeah, okay, we had, that was right. That's where we got to. Yeah. And, what? Yeah. Okay.
Yes.
The the summation of
Uh-huh.
I over 80.
Yes.
Where are they coming from this?
You mean the idea of
Yeah.
I? Okay. I is the moment of inertia based on area. So I'm going to put a little differential equation introducing this without proof. But basically, I is equal to the integral of y squared dA, where y is a moment arm. So basically, like, I'm not going to make you do an integral, so I'm just putting this up here for, you can do that in your other classes, but we can do all geometry here. But basically what we're saying is that if you have an object and you are rotating it about an axis, that every one of the elements dA will have a different moment arm, and that's y. Okay? Then dA is obvious what this is. And these are always, I'll just put between 2 and 1, they're always definite integrals. They don't make any sense, and I doesn't make any sense as an indefinite integral. All right. Well, if you have an object that is like this, what you find is that you can look at just instead of a dA, that the y, if you look at the whole thing, will be a constant. So you can pull it out of the integral, and so you get y squared times a. Okay? whatever the limits are. I want to make that clear. You have to keep the limits here. All right, so this is what we're talking about. So when we have reinforced concrete, I'm just going to use this picture, you don't really have a physical area. This is a transformed area, but its distance to the axis of rotation is constant throughout. So it's always, so you can use this form of the integral. So for the top part, you have to use the tabulated value, which for a rectangle about its base is 1/3 base height to the third. This is the rectangle of concrete. And then to that you can just add AD squared, or in this case it's NAD. It's a transformed area for the steel. Okay? And so there are different types of moments of inertia, and they all vary depending on what axis you rotate them about. But this is the only geometric shape that we're going to be dealing with, is a rectangle of concrete about its own base, which has a moment of inertia of 1/3 base height to the third. Okay?
Are we going to need that page for our book?
Just need to know 1/3 base height to the third plus AD squared. Yeah, absolutely. Now, later on, you may get into more complicated, like, for example, if you're dealing with irrigation structures, often they will use circular pipe for culverts, what's made out of concrete, or they have sort of this, they call it CIP, which is an oval kind of a shaped pipe, like that. And if you use something like that, you're going to have to come up with more complicated geometry. But in this class right now, we're just talking about slabs of concrete. So, what's that? Complex geometry. Yes, yes, that is correct. It's a little bit more complex. However, whenever you have something like this, it's going to be well documented. I mean, there are not an infinite number of shapes that different industries use for different building materials. So whenever you do this, you'll be able to define those shapes very specifically, and you'll be able to get those numbers. Okay. So, all right. What other questions do you have?
That's about it for now.
That it? Eddie, Christian, Ben, anything? Okay, so what I'm going to do next is I'm going to stop streaming, and then I'm going to talk to you guys here about how long we're going to have to take the exam and at what time we're going to take the exam. And then I will forward that information to your classmate so that he can make arrangements with a proctor to have that same amount of time. All right? All right. So streaming done. I'll send out an email very shortly to let you know how long the test will be.